Hi guys, can you guys hear me? Yeah, I think we are live. Push this. This is good. Yeah, and let me. Hi, hi. Yeah, okay. So, what are we doing today? So, there was this competition which I saw. Numpy is all you need, right? So, so what they're saying is you get a data set, 10 levels, 2 hours, and two shots. Good luck, right? So you can only use numpy, pandas, and matplotlib, nothing else. No PyTorch, nothing. And you have to write the code for, let's say, some kind of a logistic regression or a linear regression problem, right? So I thought, why not recreate something like that and learn our way through this? Because I've done this, but like I think I'm not there yet. So let me just get the environment up. And we'll choose some kind of maybe, let's say, a cancer data set, right? So let me do this, wait. And no AI I'm going to use. So let me, so this was this breast cancer data set from sklearn, right? So let me create a new code. Numpy logistic regression .py, and you load this data set here. And by the way, is the stream going good? Let me see. Yeah, I think now we will be live. Are we live? One sec. So we are back, and let me see if yeah, we are live. So the quality looks good. So what we're doing is we're gonna do something like this, which is purely NumPy is all you need for deep learning, and we're gonna learn all the middle steps on the way. So let me just do this. So I'm just importing this from sklearn. Let me see how it is done. Some nice coffee here. Sklearn. Yeah. Data set. Let me see. So you just do this and then you load it. Right. So yeah. So let me just check how this is. So let me just see print data dot target names, and let me print data dot feature names. Print data dot shape as well. And also print data dot type. Let me just do this right here. Like this. And just run this. NumPy, yeah. Yeah, there's no data dot shape. There's no data dot type, so we'll do type of data. Just do this. So it's sklearn.utils bunch something. These are target names. So either the cancer is malignant or benign. And by the way, is the stream quality good? You guys can hop in with the questions if you want. And let's see. So answer data set features. So here, if you see the features, right? These are feature names. So radius, mean texture, mean parameter, perimeter, mean area, mean smoothness, mean compactness. So I think these are all features of that plot, or like what is it called? Some kind of a node. So or assist something, right? So let's okay, this is fine. And print data.data. So I think this data.data object. And what is the type of this? Oh, it's directly an numpy array. That's good. So we will also need numpy np and basically data.data data set equals to data.data, and let's split it into train and test using sklearn only. So from sklearn dot import utils, I think. Is this working? Oh, it's not utils. Wait. Model selection, I think. Yeah. This is good. Now train X. Yeah. So train X, val X, train Y, val Y is split data set, and then you do data.target. What is data.target? One sec. Print data.target. So data.data is, I think, the input features for 30 different features, 569 rows, and data.target is, I think, the labels of those features, right? So okay, and what does data.target of 10, 50, 85 do? I think this is just a array, right? So we are getting 3 examples, I think. Just so if I print this will just be zeros and ones, I think. Yeah, 0 and 0. That is fine. Now once we have that, let's see. So train X dot shape, print train Y dot shape, val X and val Y. So for 445, 30, 40, 55, 114, 30, 114. I think test size is 20%. So that looks good. So 114 times 5 will be the summation of these two. 569, right? 555. Yeah. So this is it. Now we have the data set. Now the main challenge, how do we use numpy to train a model, right? So let's switch off the suggestions for now and really try to do this. So training model to predict. So if we are using numpy with 30 features, right? So for logistic regression, right? We will, we have to create a neural network basically. Let's first create a single layered one. So y equals to, so for one variable it is mx plus c, right? And for multivariable it is w1 x1 plus w2 x2 dot w30 here in this case x30 plus c. Okay. And with this you need a sigmoid, right? And y equals to sigmoid of y. So what does sigmoid do is basically it shrinks the thing down to 0 and 1. That's what a sigmoid does. And I think that is it. So if you look at a sigmoid function, this is what a sigmoid does. So it's 1 upon 1 plus e power minus x, and it basically shrinks it down to 0 and 1, right? So whatever is the prediction of that linear layer, you get shrunken down to 0 and 1, which is what we want, right? So let's try this simple thing and we'll find the errors on the way. Okay, so we have to first do weight times the input layer, right? So input is what? Predicts. So answer. So let's say predict out equals to y. Let's keep y only. So y is, let's say there's a weight matrix, right? So weights equals to numpy dot random dot random. So you need numpy, you need np, and what should be the length of it? So we have so input train x, right? This one is as we saw, it is 455 comma 30. 455 rows, 30 columns. So we would need 30 tag comma 1, right? 30 weight on these things. So this should be 30 weights for 30 features. So x1, x2 are like, let's say, the features for each input, and w1, w is 30, right? So we will need, this is 30 comma 1, or let's say just 30. So here will be inside 30 comma this, and d type will be float 64 is fine, I think. So let's not put anything, and let's print weights dot shape, and let's do this. Let's do this. That's good. Oh yeah, I remember you, the code guy. I stopped streaming in between. And like, I was in this new job I got, But now like I'm too much into vibe coding and I want to relearn like pure ML and pure coding, right? So yeah, welcome to the stream again. What do you want to learn? Can you teach me how to understand grids? Grids as in what? So numpy, this is good. A tuple object cannot be interpreted as an integer. Oh yeah, I think let's do this. So let's remove all the prints. Grid as grid means like what? Determinant or like matrix or like simple grid? What kind of grid? I also don't know, bro. So yeah, matrix, right? So that's what I'm trying to do here. So this is train.x is 455, 30, right? And this is 30, 1. So we are just gonna cross multiply this. So weights.shape 30, right? And what we're gonna do is you're gonna x into the weights to get like, so this is y equals to, oh, we don't want those suggestions, let's snooze. Y is x, train x, and you can do this into weights. So this is just cross multiplication. We are doing 455, 30, and you are doing cross multiplication with 30, 1. I think this should be right. So we'll get, I'll just count on this, 455, 1. So one prediction. So let's print y.shape yeah, bro, that happens. So if many companies are cutting due to this AI and vibe coding shit, right? So you really need to know the very details of the things. So you shouldn't be replaceable by AI. So sorry to hear, bro, but keep grinding. I'm also in some similar kind of situation, but yeah. So y.shape, hop along, code along with me. You'll learn and definitely, bro. So this should be, let me see, it's 455. So this is good. Let's remove this also. Yeah, so now we have the output, and what we want to do is we're going to do some sigmoid on this. So y equals to numpy dot, so I don't think there's a sigmoid function, so sigmoid, and let's take in input x, let's say, and to return, so if x is smaller than equal to 0, we want something, and else we want, so sigmoid, so it is 1 upon 1 plus e power minus x, right? So here it is 1 divided by 1 plus numpy dot exponential negative of x, and if x is smaller, I think we have to use the other definition, which is basically e power x upon 1 plus e power x. So numpy dot exponential, because this one doesn't work for x smaller than 0 sometimes. it gets too big. So it is numpy dot x of x divided by 1 plus numpy dot x of x. I think this is sigmoid. Let's check this. So print sigmoid of, let's say, 1. Is this working? Let's say of 10. Why is this none? Acha, we are not returning. Lol. Return answer equals to. Okay, we can just return this actually here only. Return this and return this. Bro, I'm scared of full stack, bro. That happens. Whatever you are doing, you think that's easy, and whatever other people are doing, that's hard. So, हो जाएगा भाई, करते रहे. Abhi, there's nothing such as, data science and stuff. It's either you're doing coding, full stack, or it's pure ML, like proper LLM development. I want to go to that part. So that's why I'm grinding, back to grinding again. So sigmoid of 10. Yeah, well, this is working now. Look, sigmoid of, let's say, 100. This should be again 1. Then this is nice. Sigmoid of 2. .8. And sigmoid of 1 should be not 1. Yeah. So TypeScript वगैरह हाँ, मतलब उसमें फ्रॉम स्क्रैच नहीं, बट उसमें एक्चुअली इफ यू नो स्टफ लाइक प्रॉपर आर्किटेक्चर और मतलब कैसे चलता है प्रोडक्शन ग्रेड पाइपलाइंस फुल स्टैक में, सो इट्स गुड. बट या AI से मैनी थिंग्स लाइक फ्रंट एंड वगैरह थोड़ा चेंज हो चुका है. ऑल्सो बैक एंड अलॉट. आई एम नॉट दैट मच इनटू फुल स्टैक डेवलपमेंट. मैं ML ही किया हूँ, वो भी बहुत वाइब कोडिंग करके किया हूँ. सो आई हैव टू एक्चुअली गेट इनटू स्टफ. Let me do print sigmoid -1 also. Check if it's working. Yes, it is. Sigmoid of 0. This is fine. Sigmoid of -100. Yeah, so this is working. Now we have a sigmoid. So let's use it. So y sig equals to let me just snooze this again. So I have to just do sigmoid of train x, right? Train x and print y sig. Oh yeah, so I think we have to vectorize this function. So how do we do that? I think there is this, one sec. How to vectorize a function to use it. numpy.vectorize. Okay, np.vectorize. Okay, so you just do vec sigma is equals to numpy.vectorize of sigmoid. I think this works. And use vec sigmoid here. I create AI models. Yeah, it's not that crazy. So it's just different kind of coding, bro. If your AI model works or not, that is the real question, how good it works. So YSig, yeah, this is working. So we got the answer here. So now this is our prediction for the model. So def forward, basically for an input array is you just do x times, and for some kinds of weights, is you do this, and you do answer, and then you return vec sigmoid of that answer. This is to be returned, and can we just do, let's say, if I want to do, let's for now just print hi if everything is going good here. You can create your own money, Chapo, brother. Why will you do that job? Yeah, you can create your own money, but it's like आप freelancing कर रहे हो या फिर you're creating your own models. How do you sell those models? That's the question, right? So, but you have to have, you know, multiple what do you say? एक जॉब पे पूरा डिपेंडेंसी नहीं चाहिए एनी टाइम पे. यू हैव टू हैव ऑफर्स. सो उसके लिए करना पड़ेगा भाई मेहनत. My dream is to go into like a top company, because like आप कितना लेवल पे मॉडल्स बनाओगे? You can train, let's say I have a 5070 Ti, right? So I can train at max a model which is 4 billion parameter, right? So let me see. So मेरा 5070 Ti है, right? So 5070 Ti GPU, 5070 Ti VRAM, and billion parameter comparison. So here you see. So for 7 billion to 8 billion parameter, you require 14 to 16 GB VRAM, right? That is just for inference, and which is very tight. So at max we can do like 3 or 4 billion parameters. So that's why आपको एक लिमिट आया था. So you have to i5 11th gen 8 GB RAM. 8 GB RAM सिस्टम RAM है ना. मेरा 16 GB VRAM है, 32 GB RAM है मेरा. You want to see my system? You saw, right? This is my keyboard and this is my PC. No, all good. From my second job, I firstly got this system. Like I know that job जाते रहेगा, you have to have something, right? This is a good investment actually. आजकल के ज़माने में. My RAM price has doubled. My SSD price has doubled. So it was like a good investment on my part. Anyway, so where were we? Yeah. So let's see if we can forward this. So let's forward from a single this thing train X, and let's do this through the first layer, first input. So yeah, we are getting an answer. So our forward is working. This is good. There should be a big list now. That's good. So our forward function is working. Now we have to create a backward function, right? So let's see what backward should be. So now we have this forward. Now we need a one sec. Snooze this. Made a first job. Arey bro, it's chill bro. Keep doing some kind of projects. If you wanna hop in with me on some project just to get an like some experience, you can DM me. I'll paste my Instagram or something. Just DM me, or you can DM me on LinkedIn. So this is my LinkedIn. This is my name, so you can just find me. Yeah. So just DM me on LinkedIn and tell me who you are. My Discord is gone. Like my channel. Yeah, my everything is getting hacked, bro. It's fine. So we have to create a backward function, right? Expired. Yeah, just search me on. I'll update all those things also, but you can search me on LinkedIn or something. I'll reply. So here also we want X and we want weights. So how does this backward thing work? So a derivative of a sigmoid, let's see. Derivative of a sigmoid. So first we need to do is defined as sigma x times 1 minus sigma x, right? Sigma x minus times 1 minus sigmoid x. So this is sigmoid backwards. Sig backward is sigmoid of x times one minus sigmoid of you don't need weights here for now. So this is backward, right? And we have to return this. And so if let's say this is forward, let me print sig backward of let's say it was 0.5, right, for 0. So this should come as 0. Let me see. It's not coming 0. Oh yeah, this is just the derivative, right? अरे ठीक है भाई, प्रोफेशनल क्या अभी, you're a friend bro, chill. So let me just comment this and backward. So let me see. Print sigmoid of, let's say, 2, right? क्या आता है? 0.88. Let me use this here. Point 2. Okay, so we got a derivative working. Yeah, this is not an integral, so ulta nahi chalega, but fine, we got this working. Now to compute, let's say the partial derivatives to the, what do you say? So I think we have not got yet the loss, right? So loss in logistic regression. Let's go from there. So loss in logistic regression. It is, I think, just a binary cross entropy. Yeah, log loss. So what we are doing here is 1 minus pi log of 0. I am basically I'm creating a AI model and then training it on this data set. So there is this data set called as this load breast cancer data set, right? So this is basically so there are like 30 features, and like using those features we have to predict whether the person has cancer or he doesn't have cancer, right? And so we are training a logistic regression, which is a binary predicting this thing. So either you can predict 0 or 1. So 0 is he doesn't have cancer, 1 is basically he has cancer. And this is a very simple, like this is where you start ML, right? So, and I'm doing it without any kind of library. So that is why it's a bit challenging. Otherwise, it's just 2 lines of code. Just do a scalar and logistic regression and just predict. But yeah, so the formula, this is 1 numpy log loss math so if y is 1, okay, but what is this h theta? Okay, so h theta of x is basically the output which we have got right now, right? Okay, so yeah, here, so this is h theta. y sigmoid. So they are calling this h theta, and here sigma of z, right? And z is basically what was it, this? So they are calling this as sigma z, something like this, sigma z. And right, and 1 upon 1 plus sigma z train x. Yeah, this should be on sigma z. Right. So now it is right. Vex sigmoid. Right. And let's do this. So forward does this, both of these things, right? Vex sigmoid of answer. Right. So we have this. Now what they're doing is, so they are taking the output, they are doing a log out of it, negative log, and if yi is 0, they are doing negative log of 1 minus that. Okay, so why are they taking log? So let me try this. So let's do forward. So remove this. This is just for understanding. So right now what we have created is, let me just write it down. So we have h theta, right? H theta is basically sigma z, sigma of z, right? Sigma z is sigma z. So this is basically h function of theta is basically the x, right? The input, and this is sigmoid function of z, right? And what they're saying is basically z is the prediction, first prediction. So z is that linear combination. So what they're saying is w1 basically theta 1, like something like this. Yeah, so it's nothing different, all is fine. So what we have to do is now we want to forward and check basically. So let's say forward of some first row, let's say train x, and I want to do the first row, and I'm going to also print train y first row, and that's it. And let me just run this. So yeah, we need weights also. I follow. So train x, and I want here comma weights. It's fine. Yeah. So as you can see, we found this to be 1, this to be 1, which is already like a victory. So let's change this. So second example, 0 0. Okay. So random example, 1 1. What? Let's do this. Yeah, so this is almost 0 and this is 1. So this is not yet trained, right? Yeah, bro. I want to get cracked to actually get good work, bro. Money is fine. Anyways, I'm earning. So this is basically the two predictions. And what we want to do is we want to find, let's say, a loss, right? So log loss, how does this work? So what they're saying is it is either 1 minus yi. So yi is the truth, right? So if this is 1, yeah. So let me just do the loss. So let me define loss. Loss of basically, so what they're saying is if, so prediction comma yi, pred I, and this is if yi is 0. So if the cancer is not there and you predict, let's say, something else, then this should be what it should be, log of 1 minus the prediction. So whatever the prediction is there, you do subtract. Let's say the prediction is h theta is, let's say, 0.3. So you do 1 minus 0.3, which is 0.7, and then you log it, right? And if h theta, if y is 1, you do h theta, which is 0.3, you log it. So why are we logging it? So let's just first print. So what they're logging, they're logging h theta, right? So they're just logging this part, right? So numpy dot log, and they're just, why is this there? Yeah. So if yeah, this is minus 424, and so let me check. So calculate log of 0.5. So log of 0.5 is 0.3, right? Minus 0.3. And let me do log of, let's say, 0.1. It's minus 1. Log of 0.01 is minus 2. Log of 0.00001 is 6, right? And what is log of 0.96? It's a small number, right? So when okay, so what is log of minus 63? Error. log of minus 0.63. What? Log of, oh yeah, this is 0 and 1. Okay, sigmoid constant into 0 and 1. Okay, so log of 0.9999, it's a very small number. So when y is 1, log, and your prediction is also close to 1, your error should be small, right? So yeah, so when y is 1, negative log, yeah, error is small, right? Because let's say if negative log of, let's say you predict, your sigmoid predicts this, it is 6, right? So, and for let's say ln, if you do, let me do ln of 0.00, this is what your sigmoid is predicting, which is wrong, then your loss is quite big, right? So when y is 1, it is negative log, which is fine. So let me just do this. So if y is 1, my loss is negative numpy dot log of prediction. Okay. And let's say if my ln is, my prediction, which is h theta, is 0, sorry, the true is 0, then I want ln of, so if it is close to 0, then this is big, right? So this is wrong. So let me do 1 minus ln of 0.001, which is also big. Sorry. So it is ln of 1 minus 0.0001. Yeah, so this is small, right? So this is log of 1 minus the prediction. So this should be elif. Yeah, it's also negative. So negative of log of 1 minus predict. So this is your loss, which is right. And another way to write it is basically just to, you do negative of, and then you multiply y of I and 1 minus y of I. So because y of I, when it is 1, this term vanishes, the first term, the second term, and when yi is 0, the first term vanishes. So that's the same thing, this function. And here I can now just print loss forward. So let me print the loss now. Yeah, so loss is 125 for the 18th example. Let me also print the loss for just smooth this. And I'll print it for the 15th example. But divide by 0 encountered. Why? Divide by 0. Numpy dot log 1 minus spread I. Okay. Why is it dividing by 0? So exactly 1 for data point where the actual true label is 0. Okay. So numpy.log of 1 minus prediction, which is 0, right? And if prediction is 1, then 1 minus spread of I is 0. Taking logarithm of 0 approaches negative infinity. Okay. So you just have to clip, I think. numpy.clip. So numpy.clip. One sec. Let me just do controls X, answer, and I do numpy.clip, answer, comma, let's say negative 100, positive 100. This is I'm capping the loss, and here also I'll just do answer numpy.clip, answer, comma, negative 100, comma, positive 100. I'll return this. If this works now, yeah. So 100 is the loss. So for, let's say, very big losses, if we want to, how it predicts if the cancer is there in body reports, say. So it's not using directly reports. What it is doing is it is extracting features, right? So feature matlab size of the node, right? Node matlab वो रहता है ना, ट्यूमर, साइज ऑफ ट्यूमर रहेगा, फिर द कलर ऑफ ट्यूमर है, वो कलर का कुछ ये किया उसने, मतलब उसका भी फीचर में कन्वर्ट किया, नंबर में कन्वर्ट किया. देन लेट्स से द shininess of the tumor, then what is the blood pressure of the person, what is, so ऐसे फीचर्स है, राइट? इसमें टारगेट जो देख रहे हो ना, टारगेट फीचर नेम्स, लेट्स से ये देख. सो ये फीचर्स जो है, आई शो यू, ये देख, रेडियस एरर, टेक्सचर एरर, perimeter error, worst concativity, worst fractal dimension, worst symmetry. So अगर कैंसर है तो there will be some pattern in it, right? If cancer is not there, that pattern won't be there, right? So that's why like depending on that pattern you can predict the outcome. So anyway, so we're doing this now. This works. I think now it won't be an error. Yeah, I've stabilized it. Runtime error again. Why? Let me do this. Okay, just clip the predictions and I'll just return here this, and maybe this works now. Yeah. So now that we have got Yeah, so we have a forward working now, and I think in this forward, we have a loss working also. So let's find the loss for all the samples, right? So print loss forward and let's just remove this 18 etc. and this dot shape. And I'll just remove this part. I is 1. अच्छा, okay. Can I just do here numpy dot vectorize? Yeah. So this is a decorator basically. This has vectorized the function to use on the array basically. So yeah. Now this works. 455. We got the loss. Now we have to do the backward of this. So def backward. Okay. Yeah, now let's just remove this. So backward of x should basically compute the partial derivatives from loss to the parameters, right? So parameters are what? The weights. So we need the prediction, loss, comma weights, right? And so let's just do sigmoid backwards first. Back sigmoid, let's do backward sigmoid. This is again loss some x, right? Partial derivative. This is derivative of sigmoid of x. So this is vec sigmoid of x. You just do times and you do 1 minus vec sigmoid of again x and you return this. So this is the derivative of sigmoid, and you want derivative of, let's say now I think we will require derivative of all the things, right? Multiplication, addition. So what is the derivative of addition? Sum. Derivative backward sum x comma y. do you do this? Let me see how it's trying to do. So if I do this, what it's trying to do? Blah, blah. Here. Each weight. So let's say this is numpy dot zeros of like weight. So basically that's the shape of the gradients, and partial derivative of loss with respect to weight I. So it is numpy dot sum of loss times strain x y. Let me do backward of loss. Did I by loss is what again? It's if yi is 1, it is negative of 1 by OPENAI. So log of some prediction, derivative is negative of 1 by prediction, 1 by x, ln of x. So yes, so here derivative of ln of x equals to 1 by x. So this is just what we are doing is if yi is 1, then this should be the derivative. If yi is 0, it should be again numpy dot log. So 1 by negative of 1 by the inner thing, right? But again, you are doing, so what you're doing here is it should be negative of, so it is negative of 1 by it was negative of log of ln of 1 minus x, right? So it is negative of ln of 1 minus x, which is equals to, let me just snooze this. So this is equals to negative of 1 divided by 1 minus x, d of derivative of that is multiplied again times chain rule, right? Derivative of 1 minus x is minus 1. So this is 1 divided by 1 minus x, I think. Yeah. So this is the final answer, which is here 1 divided by 1 minus OPENAI. So we got the backward of the loss function, and let's just keep that decorated here. I dot vectorize, and we got the backward of loss. Now we need the backward of sigmoid, which is here. So we have the backward of sigmoid as well. Then what we need is summation and multiplication, right? So let's say we have a function which is doing sum, right? A comma b. So this will be return a plus b, right? So backward sum will be taking the backward sum for each is just the gradient is just getting fast, right? So let me search. How do we backward? So while summing, the gradient is just past, I think, right? So a1 x1 plus a2 x2 and gradient of y with respect to, let me get the notes. Notes Microsoft OneNote. So yeah, yeah. So where is draw? Yeah. So let me. So what we are doing is, let's say y equals to a plus a1 x1 plus a2 x2, right? So y of x1, let's say, and I want partial derivative of this. So it is y of dy of dx1. This is, so this is just removed, right? So you just get d a1 x1 dx1. So for summation, x plus x2 how does backward for summation work? Summation function work. Yeah, so dy of dy is 1. So grad of xi x dot grad is 1. Can you show a Python function? So backward sum. Input gradient, incoming gradient, number of inputs. So input gradient is incoming gradient times 1. Okay. So incoming. Okay guys, I think we'll continue this exactly from here sometime after. I have some other meeting. Also I'll have to study this, how this backward through sum and product should work here, right? We got this part. Okay, let's continue later. Bye guys, and stopping the stream. Thanks for hopping in. Do hop in later whenever I stream. So thank you. Bye.